I'm Mike Hawkey, a science specialist from Two Wells Primary School. Today we're talking about our involvement in the SA School Space Mission and how our school used that to get involved in the STEM program. So the idea of the space program is to put an experiment into the International Space Station for 1 year. So our students are developing an experiment that will test the shielding of electronics from cosmic radiation and some of the limitations they've got in that experiment. It has to be less than a litre of volume and less than 300 grams of mass. So there's quite significant restrictions on what they can do, but they're working through the restrictions and trying to come up with a solution that will achieve the overall experiment. Our program from the start was an opt-in program, so students could choose to be involved in the space mission. And one of our goals was to engage as many students into the STEM program as we could. So the way of doing that was to offer lots of different areas that students could choose. We weren't just looking for the most academic students. It was all about engaging them and getting students who wanted to be there and wanted to be collaborating with their peers. So we're trying to give them not just technical skills, but collaborative skills and problem-solving skills that can be applied to lots of different disciplines. So the area of specific skills that they were in was not as important as the fact that they were in teams, they were collaborating together, and they were problem-solving all together to come to a single goal. Even in large engineering companies, it's not just engineering skills that you need to make a product. So we needed people that would be involved in the media production, because part of the experiment is explaining it to others through video and publications. So we needed people who had those skills. We needed students that had good documentation skills that would be able to help us prepare the documents, along with kids who could pick up some coding skills, and also looking at mechanical design, how we'd actually design a box that would survive in the environment in space. Because we knew the space mission was going to be a multi-year program, and we wanted students that were going to be along for the whole ride, originally we targeted from the year 3s, because that would mean they would be year 7s by the time the mission completed if we were successful. And we wanted to have that opportunity. So we targeted year 3s to year 7s. And initially we had 3 classes of students interested in being involved. Of those 3 classes, about 50 of them chose space mission. But the advantages we found was when we put the kids into groups, those older students that were taking on the leadership roles were stepping up and leading their teams. We had student leaders at the program level and at the team level. And so that meant that we had students managing their own program, and we saw extra skills being developed in the students. They had to present their ideas, so generally the student leaders got the opportunity to present what their team was doing to the whole program. So then they're developing good presentation skills, as well as leading the younger students and teaching them, in effect, and learning from teaching. As the students progress through the space mission, they gain experience the longer they stay in the mission. So by the time they get to year 7 level, we would expect that they would take on the leadership roles left vacant by the previous students. And that will give them extra opportunities as part of the STEM Ambassadors program for more training, and more opportunities within the outside of school opportunities, so excursions and the like. We allocate 2 sessions a week, 2 lessons a week on a Wednesday morning. But the only reason that we can do this in the small groups is because we have some parent volunteers who are professional engineers come in and give up their time each week to work with the students in small groups, walk alongside them and help them with the skills to solve some of the problems they've got. So without those parent volunteers, it would be very difficult for us to manage the small groups with the number of teachers that we have. They're not only working alongside the students to help them develop the skills to solve the space mission, they're also providing the expertise to solve those problems that we don't expect primary age kids to be able to solve. So they're creating the electronic circuits, laying out the circuit boards, and getting them manufactured so that when they come back, our students can then use them to continue their space, the problem of the space mission. So, and they'll then the students will program on that hardware, and hopefully it will all work as expected.